All right, integration by parts. Let's say you were asked to find the integral of x times e to the x dx. Notice that is a product of two functions. One of them is not the derivative of the other one, so it's not really your chain rule that's going to be going on like we've seen in the other ones. Okay, so you can't really use u and du here. Okay. So really what integration by parts is kind of the undoing the product rule, the 1d2 plus 2d1 in a sense. Okay? So the rule is
can we open the window slightly? People seem to be hot, including myself.
No.
Not every day, please.
here is your rule for integration
Have you looked at
by
the
parts.
series?
Right?
They break.
The integral, guys.
Okay, sorry.
The integral of the function u times the derivative of v, right? So if you can write the function kind of in these terms, you'd be able to follow this rule to help you get the antiderivative of what we started with. So uv minus the integral of v du,
It doesn't make sense.
right?
X. I mean,
What?
okay. So
Okay.
that's the derivative of v?
What?
Like the derivative?
Yep, dv like d like you know dx like y. If you have y equals 5x, then dy would equal 5 dx. Kind of like how we did the u and the du earlier.
So you're gonna end up having to do,
We'll just have u's and v's and du's and dv's.
oh, so just, yeah, I just, yeah.
Yep.
What about D and D?
Yeah, it's pretty simple if you can just remember this. Okay? So the idea is to try to set it up so we have u and dv in our original in a sense, okay? So in this case, we want this to be u times dv. All right? Well, there's two options, two ways to go with this. Okay? You could let u be simply x, and then you could let dv be e to the x dx to get that u dv part. You guys agree that I'd have the integral of u dv? Okay. Or you could do, you could say that u is e to the x and dv is x dx. Okay? So there's two ways that you could separate what you have right here into u and dv. Which one's better? Okay? Well, if u is x, what would du be then? 1 dx, right?
Can we please open the
You
window?
always like that.
No? Okay.
We'll make it. Okay? If dv is e to the x dx, what's v? The antiderivative of this, which would be what?
E to the X.
E to the x. Okay? Not the worst thing in the world. Okay?
So now we know v, du.
So now we know all the other parts and we just would plug it in. Had we done it this way, du would be what? E to the x dx.
Yes.
Right? Because the derivative of this is simply e to the x dx. If dv is this, what would v be? Antiderivative of x, basically. 1/2 x squared. okay?
So it really doesn't matter which one you choose,
Well, there's definitely,
but it's obvious
yeah.
one of them is gonna be
Mhm.
easier.
so if you look at this, to do the antiderivative, or to do the integration by parts, okay, u times v will be multiplied together. So you look back, if I take u times v, that's not bad. U times v, it's okay, alright, nothing too difficult there. Minus the antiderivative of v du. If you file, that's all you got. Okay?
So,
And it's
yep, see ya.
a little fun.
So I have to do the antiderivative of v du. Okay? So let's look at this. The antiderivative of v du. So really I'd just be doing the antiderivative of e to the x dx. Pretty easy, right? If I choose this one, I'd be doing the antiderivative of 1/2 x squared e to the x dx.
Let's choose the top one.
That's more complicated than what we started with, right?
Yucky, yucky. Yep.
So clearly, this is what you would want to choose to use. How do you know which one without writing them all out and going through that? Okay, I would
Once you get used
try to get du to be as simple as possible. You want the du to be as simple as possible, basically. Okay? So when I look at this, and I think, okay, I could let u be x, then du is simply 1. I like that. That's pretty simple.
1 dx.
Okay? If I let u, yes. If I say u is e to the x, then du is e to the x dx. That's not as simple. Okay? So I try to keep the du very simple, and that usually helps. Okay? So, not choosing that one. Okay? So the antiderivative of u dv equals u times v minus the integral of v du. That's our rule for integration by parts. Okay? So, I've set u equal to x, and I've set dv equal to e to the x dx. So really, here's what I have. U times v, so e to the x, right? Minus the antiderivative of v, e to the x, du, dx. What's the antiderivative of e to the x?
E to the x.
E to the x. Okay? And then keep in mind we were doing an indefinite integral at the very beginning. So plus c. There's your antiderivative.
Why did you have to choose U and V? Those two are so alike that I keep messing up
Yeah.
the two. Because my U's aren't that good. You should
Change them to W's and Z's. There you go.
Yeah, dogs and cats.
There you go.
Probably not C's, because you have to
Okay.
use C's and D's.
That also makes math more fun.
When I did this, when I did the practice to kind of refresh myself on this, just to kind of trust that it was working out, remember what can you do to make sure you're correct?
Do the
Do the
derivative.
derivative of this, which would involve the product rule. It's good practice on your product rule. 1d2 plus 2d1. Okay, minus, that's pretty easy. Okay, I'll show you. I'm serious, I did it. I think I did it about the first 4 times, so, but you guys are probably smarter than me.
Yeah.
So,
I do not
love
claim.
1 d2 plus 2 d1 minus the derivative of that is that, and then plus 0. So x e to the x plus e to the x minus e to the x plus 0 would just be x e to the x, right? Because those would cancel, and that's what we started with, so we did good.
You gotta love it.
Okay? It's kind of a way to check your answers, because I know that's important. For a lot of you, as you're going through them, just kind of confirm what you're doing is right. Okay? So there's an example of integration by parts. Their guidelines. They say let dV be the most complicated portion. And then, like we said, let du be a simpler function. So if you can kind of follow those two guidelines, I think that'll help you in your setup. Okay. Let me do another one here.
Yes.
Yes.
Maybe.
Everybody got that written down that needs it?